folks. This is the first lesson on Unit 2, Day 2. So you should have out your Day 2 notes and be turned to the part that says gathering like terms. So this is in our algebra section. We're going to be talking about how to simplify expressions that have algebraic operations in them. So simplifying, remember, means like adding, subtracting, multiplying, dividing, doing some operations to write something in a simpler form, sort of similar to what we did with BEDMAS. But now it's not just going to be with numbers, we're going to have variables as well. Anything with variables, that's what we're dealing with in algebra. So the first big idea here for our gathering like terms, or this section of simplifying with algebra, is this definition right here. So I want you to make sure you have this written down. This part I'm circling in red. Like terms are things that have the same variable and the same exponent. So please take a second and copy that in your note. Highlight that somehow that you will remember it. So in this table, I see some things that are listed as being like terms. So for instance, here I've got 2x and 19x. Those are the same variable because they're both x's. They have the same exponent because they don't have an exponent. Similarly, 4w and minus 10w, they're both w's. Same with the next one with the r's. The next one after that, 32a squared and 9a squared. Those both have the same variable. It has both a's and it both has the same exponent. They're both an exponent 2. Now let's take a look at some in the other chart, in the other side of the chart, that are not the same variable and exponent. So they are not like terms. For instance, here, 2x and 19a. Those are different variables. X's and a's, not the same thing. The next one looks like it might be like terms because I see a w and a w. But remember that like terms also have to have the same exponent. So this one is not the same because one's squared and one is not. The next one, 12r and 12s, obviously r and s are different variables. And here, 32a squared and 9a cubed, these have different exponents. Even though they're both a's and they both have exponents, they don't both have the same exponent. So it has to be the exact same variable part and exponent part. The last one, this one has 8y, so I have a variable, and 5, no variable at all. So that can't be a like term because it doesn't have a y. So that's sort of what we're going to be looking for. And we'll do this a couple different ways, sort of visually and some algebraic examples. So you may have seen in grade 7 or 8 something used called algebra tiles. And we're not going to have these out in class today. We may take a look at them later for people if you're kind of having a harder time with this concept to go back to a manipulative. But what they are is basically little plastic pieces, and they're different sizes. So there's this big square that represents x squared. And then there's a kind of bigger rectangle, and that represents an x. And then a small square that represents a 1. So if we are trying to add or subtract with algebra, we can't combine things that are different from each other. So x squared and x are different shapes. So when we're adding and subtracting, we can only add and subtract things that are exactly the same. And I'll do one example with kind of the diagrams of these tiles, and then we'll do some without tiles as well. So in this first example, I'm going to draw them out. Remember that we've got a big square that represents x squared. A rectangle represents x, and a little square represents 1. Those are our things that we have. So this first term, or first piece of my algebraic expression, is 2x squared. That means that I have 2 of those ones, 2 of the x squared. So I'm going to draw that out. That's 2 big squares. And then the next piece is that I'm adding on 5 x's. So the x's, remember, are the rectangles. So I'm going to have 5 of them. So I'm going to draw that out too. 1, 2, 3. Pretend these are all the same size. 4, 5. And the next thing is that I have plus 3. Now 3 is just a number, and the only one of these shapes that has just a number is the little squares, and they count 1 each. So I'm going to draw 1, 2, 3 little squares for that plus 3. So here I've got my 2x squares, the 5 x's, and then the 3 1's. I'm going to keep going and draw for the next set of things. I've got plus 4x. So 4x, that's the x's. I have 4 of those. So I'm going to draw those out. And you'll kind of see as I go here, this process is kind of a long thing to draw out your shapes every time. So we're going to move past that, but it can help at least once to sort of see how it works. Then the next thing I have is plus x squared. So just one of those. I don't have a counted number of them, just one. So I will draw my x squared. So that's the big block. And then I have plus 1. And remember, that's just the little squares. So I'll add that in as well. So if I'm counting these up and adding these up, I'm going to have to count things that are the same as each other. So the first thing I'm going to count is these x squareds. How many of the big blocks do I have? I have 2x squareds at the start, and I have 1x squared over there. So altogether, what I have is 3x squareds, because I have 3 of those kinds of blocks. Then I have 5 of the x blocks here. I have 5 of those that came from that 5x, and 4 more over there, and these are all the same. So altogether, I have add on 9 of the x blocks. And then the little squares, the 1's, I've got 3 here plus 1 over there. So altogether, I have 4. So that's what we're going to be doing. This is the math that we're going to be doing. But when we're doing this, we don't want to have to draw it out every single time. So what I'm going to do is show you how we're going to gather these like terms right from the algebraic expression. So I had x squareds listed here. I had 2x squared plus x squared, and that became my 3x squared, because I had 2x squareds plus 1 more x squared. I also had 5 x's plus 4 more x's, and that gave me 9 x's. Then I also had plus 3 and plus 1 more, and that became plus 4. So that's the work I'm going to be doing. I'm going to, for all of these examples, try to add them up in their like terms. And remember, like terms means same variable, same exponent. So first thing first is to identify which things are like terms. So in A, the first one's pretty straightforward, these examples. I have 10 x's plus 3 more x's. If you had 10 of those x blocks plus 3 more of the x blocks, how many would you have? You'd have 13 x blocks. The next one, do we have like terms? We have both of these pieces of my expression have a y. There's no exponents, so we can just add or subtract. Adding and subtracting is the same, but here we've got a little bit of a trick. I see a negative sign in front of the 2. So if I had negative 2 y's and I added on 8 more y's, negative 2 plus 8 would give me 6y. And we keep the variables and the exponents exactly the same. The next one, I have 5x squared minus x squared. Now, it's important to know if there's no number in front of a variable, it always counts as a 1. It means that there's just one of those. So these are like terms. I see that I've got an x and a squared on each. Same variable, same exponent. Now I'm going to add or subtract, and in this case it's subtract. I've got 5 minus 1. So if I have 5x squared tiles and I subtract 1x squared tile, I would have 4x squared tiles. So here's our rule. Remember, we need the same variable and exponent. And my rule is to add or subtract the numbers. That's called the coefficient, the number in front. And you keep the variable and exponent the same. It's sort of like a common denominator. When you get a common denominator, they've got the same denominator. So when you add or subtract, you keep the denominator the same. With these, we're doing like terms. We have to have the same variable and exponent. So when we add or subtract, we keep that the same because it was the same as when it started. With this next one, it's not too tricky to recognize that these would be like terms. We've got a y for each. The little twist on this one is that we have a double negative. I don't like those double signs because this is the same as saying 8y. Remember, minus a negative from our work on integers means plus 7y. And now that's easier to deal with. We're going to add or subtract the coefficients, the numbers out front. So 8 plus 7 is 15. And keep the variable and exponents the same. So the last one adds a little bit of a twist. I see that this term, the negative 4x, and this term, the 5x, they're both like terms. They both have the same variable and exponent. The 2 is not, though. The 2 is like a different thing. And you may want to use like highlighters or a colored pen to sort of help you keep your work organized on these, because we will have some things that are like terms and some that are different. So here I can say negative 4x plus 5x. I'm going to add the coefficients. Negative 4 plus 5 is 1, and keep the variable and exponents the same. So that's an x, but I still have plus 2. We might still have more than one thing, and that's okay. We'll do a few more examples here. So for 2, for A, I'm going to find the things that are like terms. I'm going to start looking at that 8x. So 8x, it would have something that's like terms. The other piece of this expression that has an x would be minus 3x. Remember that that negative sign is attached to the 3 that comes after it. I also have a positive 5, and it has a like term as well. It has no variable, no exponent. What else has no variable and no exponent? It would be that plus 2. So when I add and subtract here, I've got 8x minus 3x. So add or subtract the coefficients, the number parts. 8 minus 3 is 5. Keep the variable and exponent, if there is one, the same. And then the ones I underlined in yellow are just 5 and plus 2. So that'll be plus 7. So the blues turned into 5x and the yellows turned into 7. So I've simplified that. I can't do anything with the 5 and the 7 because they aren't like terms. This 5 having the x attached to it makes it a different type of thing. So I'm going to go and let's work on B. So here I have negative 6x. What would be like terms with the negative 6x? That would be my positive 2x. They both have x's, no exponents. Remember that the signs that are out front are the ones that go with the number after. So that negative goes with the 6. Here I've got a negative 7, and I kind of like to underline and scoop that sign in, the plus or minus, and a plus 4. So then when I'm doing my like terms, I'm going to say what's negative 6 plus 2 for the ones I've underlined in red with the x's. Negative 6 plus 2 is negative 4, and that has an x. The number parts, the negative 7 and the plus 4, negative 7 plus 4 more is negative 3. I'll do a couple more. And the color coding I think you're going to find is probably really helpful. So this one, I've got 3x squareds to start off. I'm going to look through the whole list of things over here. Does anything else have an x with an exponent 2? And I see one here. Whoops. Underline that in yellow. That's a negative x squared. And remember, if there's no number in front, we can make it a 1. Next term that I have to combine, if I can, is negative 5x. The plus 2 won't be like terms because that doesn't have an x, but the plus 7x will be. So plus 7x is going to go with that one. And then plus 2 is just kind of all off on its own. So I'll underline that in a different color. So now I need to think about my x squareds. I have positive 3 minus 1. So add and subtract the numbers. 3 minus 1 is 2. Keep the variables and the exponents the same. Then my x's, the ones I've underlined in blue. Negative 5 plus 7. Add and subtract the numbers. Negative 5 plus 7 is plus 2. Keep the variable and exponent, if there was one, the same. And then the last one that I've underlined in green, that plus 2, it doesn't have any like partners. It doesn't have any like terms to collect up with it. It just stays the same as itself. So we'll move on to D. Same idea. Here I'm going to start off with a 2x squared. And I'm going to look through the whole rest of this list. Do you see any others that have an x squared? And I do. I see minus 3x squared. And remember, scooping those signs that are out front. Then I see a minus 4x that I wonder if I can match up with anything. Not the plus 1. The 3x is x squared is already underlined. Oh, here's just an x. Minus x. And I remember that that counts as a 1 if there's no number there. And then the just plain numbers, they're their own like terms, +1 and +4. So now I've got 2x squared minus 3x squared. So I add and subtract the numbers. 2 take away 3 is -1, and then I keep the variable and exponent part the same. The next piece, -4x minus 1x. These are the blue ones. -4, take away 1 more. It's like getting 1 degree colder. It would be -5x. And the last ones, +1 and +4, those will just add up to 5. So make sure you've got this one copied down. Okay, we're going to keep on going. Very, very similar each time. We're going to highlight the like terms using colors if you can. If you don't have colored pens, sometimes people do like a single underline under some and like a wiggly underline under some, or like a triple underline under some, so you can kind of visibly show how you are pairing those up. So here I've got a -2x squared. Let's keep looking through. Oh, I see another x squared there. So that's a match. I'm going to color those both yellow. And if there's no number, I put a 1. Next ones, here I have +5. That one's not a like term, that 2x, not the 3x. Oh, and -1. Those are both just plain numbers. Next ones, -2x and +3x. So now I'm going to go through. Normally we put all of the x's first, and we usually start with the biggest exponents. So I'm going to do my yellow ones first. I have -2 minus 1. Remember, that's like getting 1 degree colder. -3x squareds. Then I'm going to do my x's. I have -2x plus 3x. So -2 plus 3 is 1. Keep the variable and exponent parts the same, 1x. And then I have 5 and a -1 that are just regular numbers underlined in blue. 5 minus 1 is 4. So for F, it's a little bit trickier here. We don't want to have to try and do this with these double signs. Double signs with brackets, it's just that like little bit of extra trickiness that you probably want to take care of before you do your like terms. So I don't want to write minus -3. I'm just going to put +3. Then +5x stays the same, and plus -2x squared, I'm just going to make that -2x squared and -2. So here, now we can do our like terms. I always like to clear out those double signs, minus a negative or plus a negative or whatever. 4x squared, the other x squared I see is this -2x squared. Other like terms, I've got a 5x, but I don't have any other plain x's that would go with that one. That's okay. Then I have a +3 and a -2. So I'm going to do the red ones first, my x squareds. 4x squared, take away 2x squared. 4 take away 2 is 2x squared. Then I'm going to do my x's. I've got just one that's blue, 5x. And then the regular numbers. I have +3 and -2. So a +3 minus 2 is just +1. Again, I really think that the color coding can help here. Okay, couple examples. Now, just using an application of this to figure out what perimeter is. Now, we would know a rectangle is a pretty straightforward shape. We know that the two sides of a rectangle would be the same. That one's going to be 5x plus 1, and this one's 2x plus 3. And we know if we're finding a perimeter of a shape, we're going to add up 1, 2, 3, 4, all four sides of this rectangle. So the perimeter of this rectangle would be 5x minus 1 plus 2x plus 3 plus 5x minus 1 plus 2x plus 3. So I've got kind of the one side, two sides, three sides, four sides. So that's a big expression for perimeter, and I'm going to erase this because I'm going to need to underline in my colors. But now I can simplify because I have some like terms here. And in a lot of the examples already, we only had one or two of each. Here we've got lots of like terms because I see 5x, but then I see 2x, and then there's a plus 5x again, and then plus 2x again. So I've got all of those that are all like terms with each other. Then I have minus 1 and plus 3 and minus 1 and plus 3. So now if I add up the x's that are in red, 5 x's plus 2 more x's plus 5 more x's plus 2 more x's. So 5 plus 2 is 7, plus 5 is going to be 12, plus 2 more is 14 x's. That's how many x's I would have. And then if I look at the regular numbers in blue, underlined in blue, -1 plus 3, that's 2. So I've got this -1 plus 3, I'm at 2, minus 1, now I'm at 1, plus 3 more, now I'm at 4. So that would be 14x plus 4. So that's a simplified expression for perimeter. And we're going to use that in some types of problem solving later in this unit, but that's all you're going to have to do for today. There's one more example. And this, very similar, but we've got these marks on my triangle showing that they're all the same. So this would be 3x minus 5. This is an equilateral triangle. So create an expression for the perimeter. So you're going to have P equals, the first side's 3x plus 5, plus the next side is minus 5, plus the next side is 3x minus 5. So when we gather up all of those like terms, what's going to happen? I'd have 3x there, plus 3 more x, plus 3 more x. And then I would have minus 5 more, minus 5 more. So here my perimeter, 3x plus 3x plus 3x. So 3 plus 3 plus 3 is 9x. And then minus 5, minus 5, minus 5, -5, minus 5 more is -10, minus 5 more after that is -15. So that's your expression for perimeter. So I'm going to stop there. I would like you guys to take about 15 minutes to try some of the questions in the examples in your homework. So now you're moving on to the homework questions and just the first part of your day 2 homework.